Hi guys, happy Eid to each and every one of you. I'm hiding from my family to quickly record this video for you guys because I feel like there are a lot of teachers who are not doing justice to this paper. I'll quickly demolish this paper. Also, if you hear background noises, just please ignore them because I'm back home. But I care for you guys, so I'm quickly recording this video so that you guys can easily work your way through the latest paper tested by Cambridge examination, right? So I'll write my name. It's obviously Suleiman Khan, like the Britishers say. And let's just demolish this paper. I'll go a little quick over this paper, and if you guys feel like my pace is a little fast, then you guys could slow the video down or rewatch certain parts that you think that I've gone a little too quick on, right? So I'll solve it from the student perspective. How should you guys solve it, right? So let's start. Question 1 says the diagram shows containers of gas at the same temperature. Okay, all containers have the same size. Now realize that the size is the same. So if he's asking you for the highest pressure, if the size was different, the smallest container would have had the highest pressure, keeping in mind that the particles remain constant, remain same in all the containers, right? The smallest container would have had the highest pressure because the smaller the container, the more frequently the particles would bombard with the walls of the container, exerting force per unit area, which is equal to pressure. But he's saying that the size is the same. So now what is the other thing that you guys should keep in mind if the size is the same, which would affect the pressure? That's obviously the number of particles. You know, if you have more particles in a container, that would mean more frequent collisions or more bombardments, right, with the walls of the container. And more bombardment with the walls of the container means more pressure, because you would have more force per unit area, right? So if you check all of these containers out, you have A, which has 6 particles, B has 5 particles, C has 3, and D has 4. So A has the highest particles, therefore it would exert the most force per unit area, and therefore exerting the highest pressure. Now a cooling curve is shown. A cooling curve shows you how the temperature of a substance changes as it's cooled down, right? So if you check out this cooling curve, you'd realize that you've started off with a gas, and then the gas, you keep on cooling the gas, and then there's a horizontal line. What does this horizontal line mean? This horizontal line means that there's a change of state. Now what does a gas change to? When a gas cools down, it goes from a gaseous state to a liquid state, and there's a change of state. Why is the horizontal line representing a change of state? Because you'd realize that whenever there's a change of state, the temperature remains constant, right? And in the case of cooling curve, the reason why the temperature remains constant is because the energy given out when a gas changes its state into a liquid balances the cooling effect, right? So you guys should know this fact. And then after all the gas is converted into a liquid, the liquid further cools down from W to X, and then once the liquid cools down, then the liquid also has started to change state, right? And what does a liquid go when you cool down a liquid? Which state does it convert to? You know that when a liquid cools down, it goes from a liquid state into a solid state, and after all the liquid has been converted to a solid, then from Y to Z the solid further cools down. Realize that between V and W and X and Y, you have 2 states available. You have a gaseous state and a liquid state at V to W, and after all the gas has been converted into liquid, only then does the liquid start to cool down. Only then does the temperature further decrease. And then at X and Y, you have both liquid as well as solid. But after all the liquid converts into a solid, only then does the temperature cool down. And you realize that when a gas goes into the liquid state, that's called condensation. And when a liquid changes its state, and obviously this is exo, right? Why is it exo? Because gas particles have more energy than liquid particles. In order for the gas to go into liquid, it must lose that extra energy to the surroundings. And then liquid to solid is also exo, because liquid particles have more energy than the solid particles. So for liquids to go into solid, they have to lose that energy to the surroundings, right? So that's the entire cooling curve for you guys. Now let's read the options. And that's the condensation. This process is called condensation, and the constant temperature at which a gas changes its state into liquid, that's called the condensation point. And then from X to Y, that's called freezing, obviously, liquid to solid. And then the constant temperature at which a liquid changes its state into a solid is called the freezing point. Remember, condensation point and boiling point is the same temperature, and freezing point and melting point is the same temperature. It just depends on whether you're cooling it up or heating it. If you're heating it, you'll call this the boiling point, but since we're cooling it, we'll call this the condensation point. And if you're heating it, you'll call this the melting point, this constant temperature, but if you're cooling it, you'd call it the freezing point. But remember, the temperature is the same. Now he's saying between U and V, the substance is condensing. Now, U and V, the substance is not being condensed, it's just cooling. The gas is further being cooled. Between V and W, heat is being absorbed from the surroundings. Heat absorbed from the surrounding means endo, right? But we know that between V and W, that's condensation, and that's exo, so heat is being released to the surroundings. And then between W and X, the particles are close together and randomly arranged. That's true, because between W and X, you have a liquid, and liquid particles are close together but slightly separated. So you really write slightly separated in brackets, you know. So they are close together and they are randomly arranged because you can't see any pattern. It's not a lattice, it's a random arrangement of liquid particles. Solid particles are regularly arranged. So C is the correct option. And then if you look at D, Y and Z, the substance is changing from liquid to a solid. Between Y and Z, if you look at Y and Z, the solid is just being cooled down. Also, students may also ask that, you know, sir, how do you know it's gas? This could also have been liquid. Now, realize if this was a liquid, then this would have been liquid to solid, and the solid would further cool down, but this is nothing. Then where does the solid go to? When the solid further cools down, it still remains solid. So what is this change of state? So it can't be a liquid. Therefore, that must mean that you need to start with a gas, because if you start with a liquid, it doesn't make sense, because obviously liquid goes into solid, but what does the solid go into? This is a change of state. We know solid remains solid. It doesn't go into anything, right? So this must be the gaseous state. That must be the starting point. Done. Next question. Question 3. Sample of 4 gases released in room at the same time. The gases are carbon dioxide, hydrogen chloride, hydrogen sulfide, and NO2. Which gas diffuses the fastest? Now, diffusion depends on two things. It depends on temperature and it depends on the relative molecular mass. And if he's saying they're released in room, that means he means that the temperature is the same for all. Now, what other thing affects diffusion? That's the relative molecular mass. And we know the one that would diffuse the fastest would be the one that has the lowest relative molecular mass, because the higher the relative molecular mass, the fatter the molecule and the slower it will diffuse. So we just need to calculate it from the periodic table. Carbon is 12, 16 is oxygen, times it by 2, that gives me 44. HCl, 1 is hydrogen, Cl is 35.5, that gives me 36.5. Hydrogen is 1, times it by 2 because you have 2 H's. Sulfur is 32, that gives me 34. And NO2, N is 14, oxygen is 16, times it by 2, 16 times 2, that's 32, 32 plus 14, that's 46, right? So if I'm not wrong, the one that has the lowest relative molecular mass, that's H2S, would diffuse the fastest because that's the lightest, right? So H2S, hydrogen sulfide, boom, boom, boom. Next. Sulfur atoms can form the negative ion S2 minus. Now sulfur, if I'm not wrong, it has 16 protons and 16 electrons, right? You could check that out in the periodic table. The smaller number is the proton number, and for an atom, the proton and electrons are equal. Now, S2 minus would mean that it has gained 2 electrons, so now it has 18 electrons. And now you just need to check out these atoms' electrons. You pick out the periodic table and you check this out. Argon is 18 in the periodic table, which means it has 18 protons and 18 electrons. So it has the same electronic configuration as S2 minus. Calcium is 20, so 20 means it has 20 electrons. It's not equal to 18, so it doesn't have the same electronic configuration. Electronic configuration just refers to the arrangement of electrons in shells. So if they are the same, if you have same number of electrons, then they must be arranged similarly in the shells, right? And O2 minus, O is 816, right? 8 is the proton number, remember. So 8 is the proton number, which means it must have 8 electrons and 8 protons, but 2 minus means that now it has 2 extra electrons, that is 10 electrons, which is also not equal to S2 minus. So the only one that has equal number of electrons as S2 minus is argon. So one of these atoms have the same electronic configuration. Now you have 2 isotopes. Remember, isotopes are what? They're different atoms of the same element, having the same number of protons but different number of neutrons, or different nucleon number, or different mass number, you know, or same atomic number. Proton number, atomic number, same thing, right? Now remember that isotopes also have same chemical properties. Because why do they have same chemical properties? Because they have the same number of outermost electrons. Now also realize that they have different physical properties, you know, like density, because their masses are different. So the densities can vary, etc., etc. So different physical properties, but same chemical properties, because chemical properties depend on the number of outermost electrons. So they have different chemical properties. Wrong. They have same. They have same chemical properties because they have the same number of outer shell electrons. That's true. See, both have 6 protons. 6 protons. That means they must also have 6 electrons. They have the same nucleon number. No, the nucleon number is the total number of protons plus neutrons in the nucleus of an atom, and that's not same. One has 12 and the other one has 14. Nucleon number is also known as mass number. Yeah, they have different positions on the periodic table. No, they have the same positions because position is determined by the number of protons, and T, whatever T is, you could check out in the periodic table the element with 6 protons, and that would be T. So it has the same position because the proton number is same. Next, lithium is in group 1 and nitrogen is in group 5. So lithium is in group 1 and nitrogen is group 5. Yeah. So nitrogen would need, if they were to bond, he's saying they form an ionic bond, and you realize that lithium, since it's in group 1, it loses 1 electron, and nitrogen is in group 5. So in order to complete the octet, it must gain 3 electrons, right? So it must have a charge of 3 minus. But how many lithium ions do you need to cater to 1 nitrogen? You need 3 lithium ions. That's why the formula is Li3N. 3 lithium ions for 1 N ion. 3 lithium ions for 1 nitride ion, right? So that's the idea behind it. Now it says, what happens to the electrons when lithium atoms and nitrogen atoms form ions? You realize that this is an ionic compound. He's even told you this, but you realize that this is a metal and that's a non-metals, and there's a transfer of electrons, so that's obviously an ionic compound. Now, each lithium atom loses 1 electron, that's true, and forms the lithium ion. Each lithium atom loses 1 electron and forms they don't gain electrons, they lose electrons. Metals tend to lose electrons. And then between A and B you have to check out nitrogen. Each nitrogen atom gains 3 electrons to form the N3 minus ion. That's true. Each nitrogen atom does not gain 5 electrons because it can only accommodate 3 more electrons, because then it'll have the complete octet, which is of 8 electrons. Next, for which of the compound is the dot and cross diagram correctly shown? You realize that A is wrong because hydrogen only has 2 electrons. Where in the word, if it shares 1 here, hydrogen only has 1 electron, not 2. So if it shares 1, where is helium has 2, right? So if hydrogen shares 1, where are these 2 coming from? So that's wrong. Hydrogen, again, what the hell? Hydrogen does not have these many electrons, just have 1. It shares 1 here, and nitrogen shares 1, shares 1, shares 1, shares 1, shares 1. So NH3, that's basically ammonia, right? And that C is absolutely correct, because nitrogen is in group 5 and it shares 3 electrons, right? 1 with this hydrogen, 1 with this, and 2 are left in its outermost shell, which we also call the lone pair electrons. D is wrong because he's missed out on the 2 electrons that are left in the nitrogen's shell. This looks something like this: H, 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 nitrogen and hydrogen's bond, NH3. You could also show it like this, but realize that after nitrogen shares 1 here, 1 here, 1 here, 2 are still left because it's in group 5. It has 5 outermost electrons. Which row identifies the positive and negative particles in a giant metallic lattice? Remember, metallic lattice does not have the negative particles. It does not have anions, because anions are negative particles and they are not present in metallic lattice. You have delocalized electrons, right? Cations are positive ions. They are present, but they are not the negative particles, they are the positive particles. So the positive particles are not anions, and you realize that the negative particle is not the cation, so not the anion again. So you would have cations as the positive particles and delocalized electrons as the negative particles, because that's what a metallic lattice is. It's a lattice of positive ions, which are called cations, in its sea of delocalized electrons, which are the negative particles, right? Because the electrons have a negative charge. Which formula and the name of the compound is correct? Calcium oxide, that's correct. It's a binary compound. It must end with an IDE. Calcium oxide is correct. Cobalt 2 chloride. Cobalt 2 means cobalt must have a 2 plus charge. Chlorine is in group 7, so it has 1 minus charge. Cross multiply, you get COCl2. That's the formula of cobalt chloride. The name is correct, but this formula is incorrect. Sulfur dioxide, that's SO2. So the name is correct, but the formula again is incorrect. Anhydrous copper 2 sulfate. Copper 2 sulfate. Copper has a charge of 2 plus, SO4 is 2 minus, and then the 2 plus balances the 2 minus. That's why the formula is CuSO4. Or you could just say, oh, the charges cross the 2. But that's not the reality behind things. It's just that the 2 plus is enough for the 2 minus. The charges must balance each other, right? So that's why the formula is, for 1 copper ion, you just need 1 sulfate ion. And it's anhydrous, which means it lacks water. So that is the formula, not CuSO4 twice. So D is incorrect. Which mass of magnesium is formed when 12 grams of magnesium completely reacts? Again, you're given known data. My bad, just one moment, guys. I accidentally hit the mic. Wait. Okay, yes, we are back. I hit the mic with my hand, sorry. So whenever you're given the mass of magnesium, and what do you need? You need the mass of magnesium sulfate. Whenever you're tested with a stoichiometry question, it's a very simple rule. Convert the data into moles, use the equation to find the moles of unknown, which in this case is magnesium sulfate, and convert it into whatever the question asks. The question asks the mass, so you could convert. So it's a 3-step process, obviously, right? So you can convert it later into mass. So you're given mass, let's convert it into moles. You know, mass equals mole times molar mass. Mass is 12 grams. Moles you need to figure out of magnesium. Molar mass of magnesium is 24. 12 divided by 24, you get 0.5 moles of magnesium. And then again, I don't need moles of magnesium. I need what? Moles of magnesium sulfate. So the next step is to use the equation. 1 mole of magnesium gives you 1 mole of magnesium sulfate. So 0.5 should give you how many moles of magnesium sulfate? 0.5 moles of magnesium sulfate. And then convert it into mass, because you don't need moles of magnesium sulfate, you want the mass, right? So mass equals moles is 0.5 into molar mass, which is 120. He's given to you right here. So 0.5 into 120, if I'm not wrong, that's 60 grams. Boom shakalaka, sees the correct answer. Again, an organic compound Q contains carbon, hydrogen and oxygen only. Q contains 40% carbon, and then hydrogen, and then oxygen, right? These are the 3 elements it contains. So 40% carbon, hydrogen is 6.7. So what should oxygen be? Total percentage is always 100. So 100 minus 40 minus 6.7. Let's just calculate that. What do we get, sir? What do we get? 1 second, sir. You get 53.3. Then divided by, what's the second step? He wants you to find the empirical formula. So what's the second step? Divided by the ARs, that's 12, that's 1, that's 16. Given in the periodic table, you get 3.33 here, 6.7, and I guess this is also 3.33. Divided by the simplest ratio, which is 3.33. You get what? 1:2:1. So you have 1 carbon, 2 hydrogens, and 1 oxygen. That's the empirical formula, CH2O, and all the others are incorrect. The value of Avogadro's constant is 6.02. Okay, we know that. What is the total number of atoms 2 moles of ammonia gas contains? So total number of atoms. Now realize that ammonia gas is NH3. Now, if I want to find out the atoms, remember, total number of atoms, I could do it through 2 ways, whichever one you want, right? So the first method is that if I first of all, I know that 1 mole has these many atoms, right? So first of all, I find out the molecules of ammonia. So how do you find out the molecules? If you want to calculate the molecules of ammonia, you're going to take the moles and multiply it by the Avogadro's constant. But this would give me the molecules of NH3. I need the atoms. 1 NH3 has how many atoms? It has 3 hydrogen atoms and 1 nitrogen atom. So once you find the molecules, you will multiply this bit by the number of atoms. That's 1, 2, 3, 4. So we don't need molecules of ammonia, we need atoms of ammonia. That's one way. So 8 times 6.02 into 10 is power 23. That's the one way to do it, because you first of all, I found out the molecules of ammonia, and then I multiplied it by 4 because each ammonia molecule contains 4 atoms. The other way is to take 2 moles and be like, hey, 2 moles would have how many moles of atoms? So 2 times 1, that has 2 moles of N, and then 2 times 3, that has 6 moles of H. So in total, you have 8 moles of atoms. And then you want to find the number of atoms, so take 8 and multiply it by 6.02 into 10 is power 23. Both cases you're going to get the same answer, because in the first case you're first of all multiplying 2 with this number and then multiplying it by 4, so 4 times 2 it's 8, right? And here you're first multiplying 2 to find out the moles of atoms, and then once you have the moles of atoms, you could find the number of atoms. So either or, same case. So 8 times 6.02 into 10 is power 23. If I'm not wrong, that gives me C as the correct option. You guys can calculate it. L, M, and N are electrolyzed using inert electrodes. L is conch hydrochloric acid. So it's conch hydrochloric acid. This is concentrated NaCl. Great. And that's dilute sodium chloride. Which solutions produce pale yellow-green gas at the anode? Anode is the positive electrode, right? So you realize that the negative ions are going to go at the positive electrode. Now, the pale yellow-green gas is the chlorine gas. So which of these would give me the chlorine gas? Remember, in concentrated, the halide ion always wins the race. So chlorine is going to form in this case, and this is also concentrated, so chlorine is going to form at the anode, the pale yellow-green gas. But this is dilute. In dilute, the hydroxide ion always wins the race no matter what, right? So the hydroxide wins, so in N, you're going to get oxygen, not a pale yellow-green gas. So L and M is the correct option. Next, dilute sulfuric acid is electrolyzed using inert electrodes. What are the ionic equations for the reactions that take place at each electrode, right? So ionic equation, now dilute sulfuric acid is H2SO4 aqueous. You would have the H plus ion, the sulfate ion, and you would have the OH minus ion as well, right? Now what would happen at the negative electrode? At the negative electrode, the positive ions would discharge, right? So two hydrogen ions would go together, gain 2 electrons, give you H2 gas. And what would happen at the positive electrode? No matter if you have a sulfate ion, no matter if it's diluted, no matter if it's concentrated, the hydroxide ion would, when there is 4 hydroxide ions go together, gives you 2H2O plus O2 by losing 4 electrons. So this is what happens at the positive electrode, because negative ions are attracted towards positive things or positive electrodes, and positive ions are attracted towards negative electrodes, right? Just like in this case, the hydrogen ion is being attracted to the negative electrode, right? So the positive electrode, and that's the negative electrode, the negative cathode and the positive anode. Now the negative electrode would not attract the negative ions, they would attract the positive ions, so A and B is wrong. And the positive electrode would attract the negative ions, which is the hydroxide ion. But remember, the hydroxide ion, the equation is this right here, 2H2O O2 forms by losing 4 electrons, not by gaining 4 hydrogen ions. You haven't seen anything like this, so C is correct. Then which statement about hydrogen and oxygen fuel cell is correct? It converts the chemical energy into electrical energy. That's true, because hydrogen and oxygen contain chemical energy. They're chemicals, contains chemical energy, and they are converted into electrical energy. What happens? Hydrogen reacts with oxygen, gives you H2O, right? Awesome. Hydrogen is reduced in the fuel cells? No, hydrogen is oxidized. Sir, how do you know hydrogen is oxidized? You know the equation. Hydrogen here has an oxidation state of 0, and here it's +1. So it goes from 0 to +1. That means it is oxidized, not reduced. So it's not reduced, it's oxidized. It does not produce any atmospheric pollutants. That's true. The only pollutant that the only product that it produces is water. That's the only product, the only chemical product that you have. And water is not an atmospheric pollutant. Carbon dioxide is, carbon monoxide is, nitrogen oxides are, NOx, SOx, and whatnot, right? So 3 is correct. 1, 3, the correct answer is C. Moving on. I want to go into a little detail for this reaction, because that's a beautiful options given to you guys. So the reaction pathway diagram is shown. What is D? D is basically the activation energy for R and S, which are my products in this case. It's the activation energy for products to go back into the reactants, right? So it's the activation energy for products to go back into the reactants. What is B? B is right here. This is B, right? Now what is B? It is the activation energy from the reactants to the top, right? So it's the activation energy for reactants to go into products. If this was a reverse reaction, if this was a reversible reaction, the activation energy for the forward reaction would have been B, and the activation energy for the reverse reaction would have been D, right? Now what is A? A is basically just the energy of P plus Q, right? That's the energy right here on the y-axis. So that's the energy for P and Q. And what's C? C is from the reactants to the top. That's the enthalpy change. So you're saying which of these represents the enthalpy change? That's C. B is the activation energy, not the enthalpy change. Again, the equation for the complete combustion of methane is shown. I'd need a calculator for this. What is the enthalpy change for this reaction? Now you have CH4, and if I break it down, if I show it to you, it's C bonded to 4 hydrogens, and you have O2, O bonded to 2 oxygens, and then you have CO2, which is carbon bonded to 2 oxygens, and then you have H2O, oxygen bonded to 2 hydrogens, right? These are the bonds which are being formed, and these are the bonds which are being broken. And enthalpy change is bonds broken minus bonds formed, right? Let's calculate this. So you have CH, 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 CH. So you have 4 CH bonds. Awesome. You have one OO bond, one OO bond. But remember, it's not actually one. The OO bond is 1, but you have 2 moles of this. So you're going to multiply this by 2, or should I just erase 1 and write 2 instead of it, right? So let's just erase 1 and write 2 instead of it, because there are 2 moles. Yeah. So this is the energy that would be required to break all the bonds. And what is the energy released when these bonds form? So you have 1 CO bond here, 1 CO bond here. So you have 2 CO bonds, and you have how many OH bonds? You have 1 OH bond here and 1 OH bond here. So you have 2 OH bonds. But remember, how many moles of OH bonds do you have? You have 2 moles of OH bonds. So you further multiply this by 2, because remember, this bond energy which is given to you is for 1 mole. This is for 1 mole, and you know the coefficients of the equations are also moles. So the OH bond energy, that's for 1 OH, that's for the other, but you have 2 moles of this. So you had 2 OH bonds, but you further multiplied by 2 because you have 2 moles, and this is for 1 mole, right? Remember? Done. So you just plug in the values. 4 times CH is 410, plus 2 times OO, which is 496. Add these up, please. And you have 2 COs, so 2 times 805, that's the bond energy, plus 4 times OH. OH is how much? 460. And now, if you guys sum this up and sum this up, can you guys do that for me, please? Let me also just do it on my own. Just give me a sec. This gives me 2632, and that gives me 3450. Now it's bonds broken, which is 2632, minus bonds formed, which is 3450. What do you get? You get a negative value, and that's negative 818 kilojoule per mole, and therefore the answer is B, not A. Easy. Which change is a physical change? Remember, in physical change, no new products form. The only thing that happens is the state can change. The state changes. You go from gas to liquid to solid. The appearance changes. So cracking of alkane forms new product, which is alkenes, sometimes hydrogen as well, whatnot. Evaporating ethanol. Ethanol is a liquid, goes from liquid ethanol into gaseous ethanol. That's also a physical change. It's not a chemical change. Why? Because no new product is being formed, no change in the chemical composition of matter. It was ethanol, it's still ethanol, no new products are forming, it's just the change in appearance. Fermentation of glucose produces ethanol, so new products are being formed. Neutralization of acid produces salt and water, new product. Which explains why increasing the temperature in a reaction involving gases increases the rate of reaction. So increasing temperature does two things. It increases the frequency of collisions, and like I've taught you, it also increases the percentage of particles having EA. Right, so more particles now would possess the activation energy because the kinetic energy increases. So it increases the collision frequency. Yeah, it does. It lowers the EA. No, nothing lowers the EA. Only a catalyst lowers the activation energy, by providing an alternate pathway. It increases the kinetic energy. Yes, the kinetic energy is increased. That's why more percentage of particles possess the activation energy. It increases the number of gas particles. No, it does not increase the number of particles. They're the same particles, but they just have more energy now, right? So 1 and 3 is the correct option. Next, the equation is shown. The enthalpy change is negative, so for the forward reaction is exo, the backward is endo, which would show which of these conditions will both move the position of the equilibrium to the right. So if you want to go to the right, you need lower temperature, because lower temperature favors exothermic reaction, so you're going to go towards the equilibrium, would shift towards the right. And what do you need for pressure? For pressure, you need to check out the moles of gas. Here you have 9 moles of gas, and here you have 4 plus 6, you have 10 moles of gas. So I need to go towards more moles of gas. And how do you go towards more moles of gas? By reducing pressure, because decrease in pressure favors more moles, more gaseous moles. Remember, gaseous moles, they're all gases. So decrease in pressure, boom, decrease in temperature, decrease in pressure, and decrease in temperature. So A and B are wrong, because we don't want to increase the temperature, we want to decrease it. In between C and D, we also want to decrease the pressure, not increase the pressure. Next, mercury 2xO decomposes when heated. The equation is shown. Why is this a reduction reaction? See, mercury here is +2, oxygen is -2. Here mercury is in its pure elemental state, it's 0, oxygen is 0. So why is this a reduction reaction? Because mercury literally went from an oxidation state of +2 to 0, or you could say it lost an oxygen atom, and loss of oxygen atom is reduction. So the products weigh less than the reactions. That's wrong, because law of conservation of mass says that the mass must be conserved. There are fewer reactants than products. That does not mean anything with regards to why it's a reduction reaction. That doesn't mean anything, literally. There is a gain of oxygen atom. No, gain of oxygen is oxidation, not reduction. There's a loss of oxygen atom. Yes, that's why you could call this reduction. But in fact, it's a redox reaction, not just reduction. How did you know, sir, this was +2? How did I know this was +2? Because let's suppose I did not know mercury. I know oxygen is -2, and the overall oxidation number for any compound is 0. So X equals +2. -2 shifted on the right. Yeah, that's how I knew it's +2. Next. Some information about two dilute acids are shown: nitric acid and propanoic. Remember, propanoic acid is an organic acid. Organic acids are weak acids. They partially dissociate. They have lower concentration of H plus ion, and if they have lower concentration of H plus ions, they're going to have a higher pH. That's why they have a pH of relatively 4, 5. Not that of a strong acid, because strong acids have a lower pH of. They have a higher concentration of H plus ions, resulting in a lower pH of around 1. Right? Now it says Nitric acid has a lower pH. First of all, nitric acid does not, oh yes, nitric acid has the lower pH. It has a higher concentration of H plus ions and therefore has a lower pH because it dissociates more than the propanoic acid. Yes, dissociating more means it gives you more H plus ions, and more H plus ions would mean a lower pH, aka a stronger acid, a pH of like around 1. Right? Propanoic acid has a lower concentration of hydrogen ions. Yes, it does have a lower concentration of hydrogen ions. That's why it has a higher pH. Remember, propanoic acid has a higher pH because it has higher concentration. Remember, concentration has nothing to do with higher pH or lower pH. Higher pH has to do with what? It has to do with what? It has to do with low concentration of H plus ions. It has nothing to do with higher concentration in terms of mole per dm cube. So remember, propanoic acid has a higher pH around 4, 5, or in this case 2.6 because it has lower concentration of H plus ions. Because remember, weak acids partially dissociates, and I've taught you guys that they only dissociate about around 1%. So even if you have a higher concentration in mole per dm cube, only 1% of 0.4 would actually dissociate into the hydrogen 1 plus ion, right? So which are correct? 1 and 2 are correct, therefore I'd go with A. Element E is in group 1, great, and it's a metal therefore, and element G is a non-metal, so there must be an ionic bond being formed between group 1 and group 7, right? Now it says which is true about their oxide. Okay, what is true about their oxide? Group 1 oxides are metallic oxides, metal oxides are basic oxides, and group 7 oxides are non-metal oxides, and non-metal oxides are acidic oxides. Done, sir. So both oxides are acidic, both are basic. Wrong. E is acidic. No, E is a metal, so E must be basic and G must be acidic because that's a non-metal oxide, like sulfur dioxide, etc. That's obviously sulfur is in group 6, but I'm just saying that non-metal oxides are acidic oxide. Like magnesium is in group 2, but magnesium oxide is a basic oxide and whatnot. Lead sulfate is an insoluble salt. How could you prepare a solid sample of insoluble? Remember, I've taught you guys this. Insoluble salt. Lead, how do you prepare insoluble salts? You take 2 soluble salts. So normally we take nitrates, lead nitrates, and for sulfates you could take any soluble sulfate, group 1 sulfate, ammonium sulfate, or any other sulfate which is soluble. And for lead also you could take any other soluble salt of lead, but normally we take nitrates because we already know that all nitrates are soluble. Now since titration is wrong, we don't titrate it because obviously we want to prepare an insoluble salt. Titration is for ammonium salts or group 1 salts. Now you take lead 2 nitrate and you take potassium sulfate. Yes, they're both soluble salts, and you heat to evaporate all of the water. No, that's BS, because you don't heat, you don't crystallize in this case. What do? We just mix them together. The lead 2 plus ion are just going to come into contact with the sulfate ions after they're mixed, and then the precipitate starts to form. You filter it out, and then you wash the residue and dry it between filter paper, by gently tapping it between 2 filter papers. That's it. Mix them, aqueous potassium sulfate, lead nitrate, awesome. Filter and collect the filtrate. Wrong, because filtrate is this solution right here, the soluble solution. So the soluble solution which comes down into your conical flask, he's saying take that filtrate and crystallize it. That won't give you lead sulfate, that would actually give you solid potassium nitrate, because potassium nitrate is going to be collected as filtrate, and if you heat it till the point of crystallization, what's going to happen is potassium nitrate solid is going to form and water is going to evaporate. So we don't need potassium sulfate solid, we need lead sulfate. And obviously C is the correct option. Mix lead nitrate, dilute sulfuric. Yeah, you could also take dilute sulfuric acid because it has SO4 2 minus ions, right? And lead is 2 plus. So instead of taking, normally we do this, but as long as you have the SO4 2 plus ion coming into contact with the lead 2 plus ions, because see, you would have lead 2 plus ion, nitrate ion, H plus ion, SO4 2 minus ion. The SO4 2 minus ion is going to come into contact with the sulfate ion, with the lead ion. They're going to precipitate, then you filter it, wash and dry the residue, which would be of lead sulfate. So realize that normally we take 2 soluble salts, but even if all the other conditions are not being fulfilled, as long as you have a sulfate ion that could come into contact with the lead 2 plus ion, you can get the salt, right? Because the problem with some of you may go for B, but the problem with B is talking about the filtrate. We need it as we collect it as residue, not as filtrate. No? The elements oxygen and sulfur are in the same group of the periodic table. Which statement is about oxygen and sulfur is not correct. Okay, they are non-metals, that's a correct statement, so I'll cancel this out because they need not correct statement. They have giant covalent structure, that's an incorrect statement, obviously, so I'd go for B, because you realize that oxygen is not a giant, oxygen or sulfur, they're not giant covalent. Giant covalent is obviously your graphite, your diamond, your silicon dioxide, you know, that's giant covalent structure. So neither of these have a giant covalent structure. They have 6 electrons in the outermost shell, that's a correct statement because they're in group 6, which would mean they have 6 electrons. So that's a correct statement, we need to go for not correct. They react together to form acidic oxide, yes, SO2. Sulfur reacts with oxygen to give you SO2, that's an acidic oxide, which can further cause acid rain. So that's also the correct statement, we need to go for not correct. Tennessine is at the bottom of group 7. So if it's at the bottom of group 7, what should its property be? You know that as you go down group 7, the state changes from gaseous state to liquid to solid, obviously, so it must be a black solid, not a colorless gas, and the density increases, right? That's why the color becomes darker and darker. So it must be more dense than iodine, not more reactive than iodine, because you realize that reactivity decreases down the group. The most reactive is fluorine, not iodine, right? So A is the correct statement. An example of sacrificial production is shown. Okay, steel hull, zinc blocks are outside steel hull. Which statement explains why zinc protects iron from rusting? Because zinc is more reactive than iron, therefore it has a greater tendency to lose electrons. So zinc is going to lose electrons and, you know, get oxidized itself and prevent the iron in steel from rusting, right? So zinc is more reactive than iron, so it loses electrons more easily. Yes, it has a greater tendency to lose electrons, get oxidized itself, but protects iron. That's it. Zinc is less reactive. No, zinc is more reactive. Zinc is more reactive. So B, D are wrong. Zinc is more reactive than iron, so it gains. No, it doesn't gain electrons, therefore it loses electrons. Metals reactivity means that it loses electrons. For metals, reactivity is how quickly they can lose electrons. For non-metals, how quickly they can gain electrons, right? Which statement about alloys is correct? Alloys are harder than pure metals because they contain strong intermolecular forces. No, because of different size atoms, the layers cannot slide over each other. It's not about intermolecular force of attraction. Brass contains mainly copper and tin. No, brass contains copper and zinc, not copper and tin. So B is wrong. Different size atoms in an alloy mean that the layers cannot easily slide over each other. That's true, and therefore they are hard and rigid and whatnot. There are no alloys containing carbon. That's BS, because you realize that iron contains iron plus carbon literally gives you steel. And even stainless steel is iron plus carbon plus nickel plus chromium. So alloy can contain, it can be any metal mixed with a non-metal or a metal. Separate pieces of aluminum foil and copper foil are heated. The copper foil reacts to give a black solid, that's copper 1 oxide. You know, nobody cares if you know that or not, but let's read the MCQ. The aluminum does not react. Why would it not react? Because obviously you know that it will form a layer of its oxide, Al2O3. It forms Al2O3. So aluminum is right here, but it forms a layer of its oxide which prevents any more contact with oxygen or air or whatnot. So aluminum has an unreactive layer, but copper does not. That's true. Aluminum has this ability to form an oxide layer. Aluminum is below copper. No, it's above copper in the reactivity. Copper reacts with moisture in the air, but aluminum does not. Copper reacts with nitrogen in the air. Copper does not react with nitrogen, and copper does not react with moisture because moisture is H2O, and copper does not react with H2O, sir. It reacts with oxygen but not with H2O. Done. Okay, sorry for the break. Somebody came inside my room. I've told you it's Eid, but I'm trying my best to record this video for you. Okay, so which shows carbon monoxide formation and for the reduction of iron 3 in the blast furnace. You know, how does carbon monoxide form? First of all, soot reacts with oxygen to give you carbon dioxide, and this carbon dioxide further reacts with soot to give you carbon monoxide, right? So that's how it forms. So you could literally cancel out A and you could cancel out C, so it's between B and D. That's how carbon monoxide forms, and it's not iron. The iron 3 oxide means that iron must have a 3 plus charge, O must have a 2 minus charge, cross multiply, you get Fe2O3, right? So it's not FeO, it's Fe2O3, therefore you could go for D next. A sample of river water contains high concentrations of nitrates and from fertilizers. Which statement about river water is correct? It has a boiling point of 100. That's wrong, because pure H2O would boil at 100. It's not pure because it also has nitrate. It'll boil a little over 100, because remember, impurity increases the boiling point and decreases the melting point, right? And it'll boil and melt over a range of temperatures. So it melts below 0, yes, anywhere -2, -3, whatever, but it'll be below 0 over a range, which means it can can be -2, sometimes it can be -3 depending on the composition of the mixture. It turns anhydrous cobalt 2 chloride from pink to blue. It will react because as long as water is present, it would give you a result with anhydrous cobalt chloride or anhydrous copper sulfate. But remember, anhydrous cobalt chloride is blue, so it'll go from blue to pink, not pink to blue. That's what they do. It's literally a psychological game. So, and it turns anhydrous copper sulfate from white to blue. Yes, because copper sulfate anhydride is this. It reacts with 5H2O, goes into hydrated copper sulfate. So it's dot 5H2, and this was white, and that's blue. So that's correct. 1, 2, and 4 are correct. Therefore, I'd go for D. Which statements about the treatment of domestic water supplies are correct? The water undergoes sediment. Remember, just think of sedimentation like filtration. If you have not studied sedimentation, I've taught this in my life class, but those of you who have not studied from me, just think of it as like a filtration. So filtration removes insoluble solids, not dissolved solids, right? They're already soluble. How could you trap them using sedimentation? So it doesn't remove dissolved solids, it removes insoluble solids. Similarly, when water is filtered, it removes insoluble solids. That's true. The water is treated with carbon to improve taste because carbon removes odors, right? And improves taste. That's true. Water is chlorinated to decrease the pH. Chlorination does decrease the pH. That's why you add sodium hydroxide at the end. But remember, that's not the purpose of chlorinating it. The purpose is to kill bacteria. So always remember the purpose of things. So that's wrong. 2 and 3, that's the correct option. You would go for C. And even if you thought 4 is correct to some extent, you don't have 4. So between these three, these two make the most sense. So yeah. An experiment to find out the percentage of oxygen is in polluted air is shown. The apparatus is left for 1 week. After this time, the volume is 122 cm cube. What is the percentage of oxygen nearest to the whole? Literally, it's a mathematics question, not even chemistry. You went from 150 to 122. So the difference is the amount of oxygen used up because iron would have rusted, right? Iron would have reacted with the oxygen to rust. So what's the difference? 150 minus 122. And how do you calculate percentage? Divided by the original value into 100%. So 150 minus 122, that gives me 18. 18 divided by 150 into, not 18, sorry, 28. 28 divided by 150 into 100%. If I'm not wrong, that will give me around 19%. If I'm not wrong, let's also calculate this. Calculator. 28 divided by 150 into 100, 18.67, which is in fact 19%. Nitrogen monoxide and carbon monoxide are both removed through catalytic converter. Nitrogen monoxide and carbon monoxide, obviously you use rhodium or platinum as your catalyst. Nitrogen monoxide is converted to nitrogen and carbon monoxide is converted to carbon dioxide. Carbon monoxide is oxidized because there's a gain of oxygen atom, and nitrogen monoxide is reduced because it loses an oxygen atom, right? And you could also check it from the oxidation numbers. Nitrogen monoxide are both reduced, both oxidized? No, one is reduced, one is oxidized. Nitrogen monoxide is oxidized? No, that's reduced. So D is the correct option. Carbon monoxide is oxidized and nitrogen monoxide is reduced. Propan 1-ol, which is this. 1-ol means that the OH is on the first carbon, and saying it is oxidized. So remember, when alcohols are oxidized, what does it form? It'll form a 3-carbon carboxylic acid. That's what happens, and I've taught you how this happens, right? So that's what happens, and the acidified potassium manganate would go from purple to colorless. So you go from, propan 1-ol to propanoic acid. Now, which of these is propanoic acid? These are both alcohols because there's only an OH here. There's no carbonyl compound, and COOH. This is this is ethanoic acid, not propanoic acid. This is the correct option. That's propanoic acid. Easy peasy, yaar. Bahut aasan. Again, even after all this explanation, I'm done with this paper in 45 minutes. You guys can be done with it in literally 25 minutes. I'm also explaining things, right? How many structural isomers with the molecular formula C4H9Cl can be formed by this reaction? Remember, I've taught you guys this. Whenever you're given such questions, the Cl can come on the first carbon, the Cl can come on the second carbon, it can come on the third carbon, it can come on the fourth carbon as well. But remember, when you start numbering it, you start where the Cl is the closest, right? So this will be meth-eth-pro-bute. It'll be, chlorobutane, right? Chlorobutane, but one chlorobutane. It's one chloro because the chloro is on the first carbon. So one chlorobutane, this would be 2 chlorobutane. So these two are different, great. But if you look at this is not 3 chlorobutane because now you don't start numbering from the left. You start numbering where the halo group is the closest. The halogen group is the closest. So it's closest towards the right. So then it's 1, 2. Again, this and this. These two are literally the same thing, and this, they are both 1 chloro butane. So you just have two ions. Describes the disadvantages of manufacturing ethanol by fermentation. Uses renewable resource, that's an advantage. Produces impure ethanol, yes, because it only produces 15% ethanol, and the other is because you've added water at the start to glucose, right? So you need to fractionally distill it later on. So it does produce impure ethanol. You need to fractionally distill it to remove water, to separate water and ethanol. The process requires high temperature. No, it's about 25 to 35 degrees Celsius, so it doesn't require high temperature. The process is slow. Yes, it's a batch process, right? It's a slow process, unlike the hydration process, in which you react an alkene with steam, because that's a continuous process and that requires high temperature. So 2 and 4 is correct. D is the correct option. Next, nylon is made through polymerization. The type of polymerization is not an addition polymer, it's a condensation polymer. It says which row describes the polymerization and defines the other product. The other product is water. Remember that it requires dicarboxylic acid and diamine. And how does a dicarboxylic acid and diamine form? The carboxylic acid loses the OH and the amine loses the H, and that gives you H2O. In condensation, always a byproduct is formed. So D is wrong. Which shows a green precipitate. Remember, you need to know your ions. You need to know the color of your ions. This is tested in the exam. What shows a green precipitate? It's the iron 2 plus ion or the chromium 3 plus ion. But it's saying that it dissolves in excess sodium hydroxide. So then it's the chromium 3 plus ion. Iron 2 plus does not dissolve. It remains insoluble. It's just a green precipitate. Done. What is the RF? How is the RF value calculated? It's not the distance traveled by the solvent, it's the distance traveled by the substance, or you could say the analyte, or whatever. The spot, the analyte, the substance divided by the distance traveled by the solvent front. That's true. So B is the correct option. C and D aren't correct because there's no division here, and that's not how you calculate it. And that's it, literally. That's the 2025 May-June paper. I went over it a little quickie, but it should do the job. Yeah, done? Okay, bye-bye, ciao, Allah Hafiz, bye.